In the test scene, there's a small problem when we move the shape. It affects the focus of the buttons in the GUI. So what we need to do is set the input as handled on the script that does the key handling. So we go to the script. And at the bottom of the input event handler, we're going to put getTree.setInput as handled. Run the scene again and add a shape. Now, when we move it, the focus is no longer affected by pressing the arrow keys. Also, the shape rotation was back to front, so we want to swap the values in the rotate grid functions in the shape data script. So we go to the shape data script and we swap these values around. Like so. And in the main script, let's add more meaningful names to the rotation constants. I'll change left to rotate_left and right to rotate_right. And let's find where they are down here. Change them there as well. Okay. And at the start of the game, when we quickly move a shape to the left, it's possible to get it stuck in the left corner so it doesn't drop. So I want to make a small change to the place shape function in the main script. So first of all, we don't need to have the print of the grid position anymore. So instead of elif, we're going to have else there, and then move this statement here. Move that into here where we go, or that, and that. And we only add tiles if we're inside the grid. Now check if it works. Add a shape. And yes, we can no longer move it past the edge. Now let's commit the changes to the repo. Add a message and then submit. Now let's add some setter functions to the GUI for level, score, high score and lines. And add in the variables for these. So for level, we'll have a default of 1, and then it will call set level when we set it to something, and we'll get the value directly when we read the value. So when level is set, we call the function set level with the value, and find the level node and set its text value to the value passed in, and we assign the value to the actual level variable. And for score, we call set score, and value is added to the text value of the score node, and the value is set to the variable of score. And high score, same kind of thing. The high score node text is set to, actually not the same thing, we format the value so it has leading zeros, and there's 8 digits in total. This is because the GUI width is defined by that high score value. And let's add a function to reset the stats. So this has default input values of high score equals 0 and score equals 0, lines equals 0, level equals 1. And we can, when we reset the stats for another game, we pass in the current high score. And using self here makes sure that the setter functions are called when the value is assigned. And let's add a settings function so that when we load values such as high score and music and sound settings, we can set them. So this has a data input object which contains the high score value and the volume settings for music and sound. So we find node music and set its value to the data.music value, And similarly for sound, we set its value from the data.sound value. And again, we commit these changes to the repo. GUI functions added. In shapes, we no longer need to print out these data coordinates, so I'll comment that out and get rid of a spurious space at the end of that line. Next, we want to have a function in the GUI to set the tiles of the next node. So we've called it the setNextShape function, and it has a shape of type shapeData as its input. So this function, we first of all clear the cells in the next node, and then because it's arranged in a vertical manner and the shapes drop in, and the shapes are by default horizontal, they occupy the first two rows of the shapes grid. So this for loop will go from 0 to the number of columns of the shape -1, and then the row will just deal with two rows, the first row and the next row. If there's a tile in this position of row col, and we set the tile in the next node's grid based on an index value of the eye, and this has the effect of twisting the shape by 90 degrees, and we set its color to the color of the shape. And again, commit to the repo with a message, next shape function added to GUI. Now let's add a function to update the high score value. Call it update high score, and if the current score is greater than the high score gets set to the current score. Now let's add an add to score function. So it's called add to score, and then we input the number of rows that have been cleared by the player, and we keep a tally of the number of rows for display in the stats. So we add the rows to the current number of lines that have been cleared, and then we work out a value for the score that increase. So this little formula goes 10 times the integer value of 2 to the power of the number of rows -1. So it will go, if the minimum number would be 1 row cleared, so that would be 2 to the power 0 would be 1 times 10, so we'd add 10 points for clearing 1 row, and then it prints added so many points to the score. You know, where it says %d, that means put a decimal number in that place, and then this says the next value is the one to apply to this point there. So then we add the score onto the GUI.score value, and then we call our new function update high score to check if there's a new high score. Now let's test these new score functions. Let's go to the ready function and we'll reset the stats, and then add some simple test code, a loop which goes from over a range of values and adds to the score. And we should see in the output window a printout of the score being updated. And there we see it's gone, added 0 to the score, 10, 20, 40, and so on. Oh, it's got 0 because the first value we passed in was 0, but in the game the minimum would be 1 for 1 row. And we can see that the score and the high score are correctly displayed. Again, commit the changes. We added score functions, so commit. Now let's consider the start of the game. So it'd be useful to have a random order of delivery of the shapes. So let's put randomize in there, in the ready function. This seeds the random number generator with the current time, I believe. So in the start game function, we want to clear the grid, and we will reset the stats, passing in the current high score value. And also we want to get a new shape and drop it into the grid. So for this we will create a new shape function. And we will call this function from the start game function. So when it gets called, it will check if something called next shape has been set, and that is a variable that we need to declare at the top. So next to our shape data, we will put in a variable for next shape of type shape data. And here we've got a constant called start position. So let's put the constant in there, but we'll also have an end position. Start position is the cell position where we position the shape when we add it to the grid. Then end position is like the top point of the stack to determine the end of the game. So 25, that's 2.5 rows down inside the grid. Now if the next shape has been set, we set the current shape to this next shape. Otherwise we get a new shape from the shapes auto load. And we set the next shape to a new shape. And in the GUI we call our new function set next shape with this value of next shape, so it gets displayed in the GUI's left side grid. And then reset the position in the cell in the grid to the start position and add the shape to the grid. And here we have a new function we're calling normal drop. This is a timer based function, so we want to add a timer to the scene, the main scene. Let's call the timer ticker. Returning to the script, let's add in our normal drop function. So this function, when it's called, finds the ticker node and starts it ticking with a certain tick speed, which we need to define. So the period of the tick will depend on the level we're at to make it drop faster as the level increases. So we divide this value of tick speed by the level that we're on. Let's define the constant for the tick speed. So I'm setting tick speed to 1.0, and there's another one we're going to use called fast multiple for when you're doing a soft drop, so when it has to be moving faster than the usual tick speed. So that's going to be a multiple of 10. So I mentioned soft drop. Here's a function for the soft drop. So we stop the ticker and then we start it again with a faster tick speed, so or a shorter period, which we get from the same calculation but divided by the fast multiple. So that will make it 10 times faster. And finally there's another hard drop we need to be able to do. So this will go at maximum speed, so it'll be tick speed divided by max level. And finally we've got a function here called level up. This will increase the level based on how many shapes have fallen up to a maximum level. So let's define the level up function. So we want to keep track of how many shapes have dropped, so let's have a variable called count. And then every 10 pieces that have dropped will increase the level. I'm not sure if that's the best way to do it, but we'll see how we go. Var count equals 0. So now we need an increase level function. So in the increase level function, if we haven't reached the maximum level, we add 1 to the level, and we also changed the period of the ticker to a faster speed based on the level. So we go tick speed divided by the level for the period. And we need to define the max level constant. So for now, let's put it in as, say, 100. And we want to stop the ticker when the game is over. So we go ticker and call it stop method. Okay, let's see if the changes work by running the game. And we can see that the stats have been reset, and we got 8 digits of zeros and level 1. The score's 0. And we see that this code has worked in the GUI to show the next shape, and then the current shape has been dropped into the scene. So again, let's commit the changes to the repo and call, I'll add a message, added ticker. Okay, now let's add some functions to move the shape, starting with moving left. So this function, move left, it takes the current grid position and using the column width of the grid, we get the horizontal position that we're at. And if it's greater than 0, it's okay to move 1 position to the left. So move the shape to a new position, 1 position to the left of the current position. For moving right, we do the same thing, but we check that we are not at the rightmost column of the grid. If we're not, then we can move 1 position to the right. Now for downwards movements, we need a ticker timeout callback function. So we go to the signals panel and connect the timeout signal to the main script. So we've got our callback on ticker timeout. So on each timeout, we want to move the position of the shape down 1 row. So that is just the new position will be the current position plus the number of columns in the grid. Now if the shape can move to this new position, we want to add something to the score if the player is entitled to a bonus. So if they're soft dropping, we can add to the score. If it's normally dropping, then nothing would be added. So this bonus should be a variable defined at the top. So var bonus equals 0. And we want to check if there is a new high score. If we were unable to place the shape in this new position, we're going to check if we've reached the end of the game or we want to lock the shape into the grid. So if the new position is less than or equal to the end position, i.e. it's stuck at the top of the grid, it's game over. Else we lock the shape into the grid because it can't drop any further. Next we want to check the rows, see if we've cleared any rows, and then get a new shape and put that in, drop it into the grid. So here is the check rows function. So in the check rows function, we're going to scan the grid from the bottom to the top and look for any cleared rows. So we start with an index of the grid size -1, and let's have a value for the horizontal displacement of x equals 0, and then a counter for the number of rows. So while I is greater than or equal to 0, i.e. it's still pointing at a cell on the grid. If the cell is occupied, we add 1 to x, and we move our index into the grid left or up by 1. And if x has reached the column count, we have found a complete row. So we add 1 to the row count, the rows count, and x becomes 0 again. And we keep looping around, adding up the number of rows that we've found. Or during scanning of a row, we have a non-empty cell. That means It's not a complete row, so we can move to the next row. So first of all, set I to the rightmost column of the next row by adding to it the value of x, and then set x back to 0. And if the number of rows is greater than 0, we want to remove the rows that we've discovered so far. So we're going to have a remove rows function passing in the current index value into the grid and the number of rows to remove. So after that, we set the row counter back to 0 and move the index value I to the next row. Next, we want to have this, and we'll keep going until we've got past the top of the grid, and then return back to here and add a new shape to the grid. But now we want to have this, create this function remove rows. And here is that function. It's first of all, we add to the score and passing in the number of rows, and we print here we've found how many rows we found, print to the output window, and number of cells to remove equals the rows times the columns. So let's go ahead and let's hide these cells initially. For an effect, we're going to make them disappear, pause, and then move all the other cells down in to fill in the spaces. So we're going to loop through the number of cells, and we get the child of the grid that we're pointing to, and we set its color to transparent. This will erase all the cells in the rows that we want to remove. Now we're going to have a pause function which will pause the game. So here is the pause function. We pass in a value saying by default it'll be true, we do want to pause, or if we pass in false it will unpause the game. So to do this pausing, we get the tree and it has a paused value which we can set or not set with the value. This will have the effect of pausing everything in the game, but we want the music player to keep playing. So in the pause mode, instead of inheriting, it should be set to process. So when the game is paused, the music will carry on playing, which we want, as we're just going to briefly show the removed cells, remove rows. So back to the remove rows function, and we paused, and after that we just want to have a brief period of showing the missing rows. So we go yield and create a timer with I've put in 0.3 seconds, so it'll be a 300 millisecond timeout. When this timer times out, it will carry on because we're using the yield function. So the next thing we want to do is unpause and let the game carry on playing. So the next thing actually is to move the existing cell, the remaining cells down to fill in the gap. So we have this variable called to, and we're going to set it to the place we want to move to, which is I plus the number of cells. So again we have a while loop, and we have a variable to, which is where we want to move the cells to. So it will be moving from the current position down the number of cells that we removed. So okay, when I is still on the grid, we're going to move from the I position to the 2 position. In this case it's the grid of true false values, the virtual grid showing which cells are occupied or not. So we're going to just copy from the I position to the 2 position. And then on the visible grid we want to set the color of the tile. So again we get the child at I, its color value, and set the color value of the child at the 2 position. If we're at the top row, there'll be nothing to copy into that row, so we're going to set all of the top row cells to false. In both the virtual grid and the visible grid, they'll be set to transparent. And these are the looping values, and keep going until the while loop reaches this condition. So that will remove all the rows. Now we should be able to test this by running the game, but before that we have to remove this timeout feature we had in there before. Okay, let's run the game. Let's set the music volume down. New game. And the shape is dropping. When it gets to the bottom, it can't go any further, so it should be locked into place. And the new shape should fall. Let's set the GUI level to say 10 to get the speed up when we test the game. Okay, play and new game. These are unfolding nicely and should stack up and then bring the game to an end. Yeah, it works great. And try a new game. And we see that the level has increased. We can remove the increased level call and save the game and commit the changes. Added ticker callback. Commit. Now let's capture input events and respond to key presses. So we put in the function override for underscore input. And here's our code. Now first of all we check if the state is playing, then we want to respond to keyboard input. And if the event is action pressed UI page up, we want to increase the level, so we call the increase level function. And if we have UI down, we want to do a soft drop and give the player a bonus for every row that he drops down at this faster rate. If we release the button, the down button, then reset the speed to a normal drop rate and the bonus to 0. And if the action pressed is accept, like the space bar, we will do a hard drop. If we press the left button, then we're going to move to the left. I'll come back to this line in a minute. And if the action pressed is UI right, we'll move to the right. If we press the up button, we want to rotate the shape. If we hold down the shift at the same time, we're going to rotate to the right. So we call move shape function with the current position and rotate right constant. Otherwise we call the move shape with position and rotate left constant. And if we press UI cancel, like the escape button, we will initiate a game over. So you can start a new game without completing it. Yeah, we want to avoid interfering with the GUI buttons, so the focus of them. So if the event was a keyboard event rather than a mouse, for example, we call the getTree method of set input as handled, so the input event doesn't propagate any further. So you can see these functions we call hard drop and soft drop, increase level. We've already defined those functions before. Now when you want to move left, you want to several places, you could tap the button, tap tap tap, or move right, tap tap tap. But usually you expect like a repeat effect to happen, so we're going to have a left timer which gets started as soon as you want to move left. So there'll be one immediate movement left, and we'll start this timer. And if we hold our finger on the button, after this wait time, the callback function for this timer will be called, so we can move left automatically. So we will add this timer And when we release our finger off the button, we want to stop actions of this timer, so we will call the stop function on the timer. And we do a similar thing for the write of a write timer. So let's add those two timers. Timer create, and this is going to be called the left timer, and right timer, Control D, right timer, and add callback functions for these. Connect to the main node. Okay, let's look at these callback functions. We didn't declare the wait time constant, so let's add that to the top. So we add the wait time and make it 150 milliseconds. These were arrived at by experimentation. And we're going to have another one. There's like an initial wait time, and then it's going to switch to a faster repeat delay, which we're going to set at 50 milliseconds. So 0.05 seconds for that. I'm going back to the callback functions. So this function will be called when the wait time has passed, and then we want to set the new wait time to repeat delay. And each time the timeout happens, we're going to move left. And then we're going to do a similar thing for the right timer's timeout. Moving left, moving right, soft drop, hard drop, hard drop, hard drop, and rotation one way, hold shift, go the other way. Yeah, it's working great. Working nicely. Oh yeah, the repeat works as well. Look. Excellent. Yay, we cleared a row. And the score was added. So to pause the game, when the GUI pause button is pressed, we should call the pause function and remind ourselves to set the pause mode of the GUI to process. Let's just check if we did that. I don't remember doing it. So inspector pause, and we want to unpause after we resume. So we call pause with false to unpause the game state. So let's have another test of the game. I want to see if the music continues to play when we clear a line. So let's quickly make a line. So this should clear, and it carried on playing. Yeah, great. Oh, I didn't check if I can level up. So it's level 4 now, so if I go page up, possibly hard. New game. New game started with a high level. So when we start a new game, we need to reset the stats but preserve the high score. So we'll start a new game and check that the high score is preserved and the level gets reset and the scores reset. So, yes. Finally, commit those changes. So we added the keyboard control. Commit. Now let's add save and load functions to save the high score and music settings. So we have save game. Oh, we've got a file name, which we will save to and load from. So in the constants, let's add the file name. So we'll save it to the user data area, and I've called it tetron.json because JSON is the data format that we will use. So when saving a game, we form a data object, and we'll have the music key as we'll set the music value to GUI.music and sound value to GUI.sound, and save the high score from which we get from GUI.highscore. So then to save it, we go var file equals file.new, then you open the file. For writing, we'd open the file name and file.write, and then we store a string which is formed by taking the data object and going to JSON format, which is a string format. So the data object is serialized, we say, and we save it as a string to the file, and then we close the file. And loading the game is, again, we get a file prop object and from file.new, and we just check if it exists. We can't open it unless it's already been saved before, so we say, does the file name exist, and if so, open it for reading. And then we go var data equals parse JSON from the file which we get as text. So it should decode this JSON into the data object, and we print it out just to check it did so correctly. And then we call our settings function on the GUI, which sets up the stats with and the slider values from this data. So we will call load game from the ready function just after resetting the stats. And when the game is over, we should save the game. So we just put it after the end of this game over function. We call save game. And let's see if it works. So new game, sliders down, and drop some shapes in. Get a score up. Okay. And now that should have saved the data. So if we close it, now if we run it, we should get that score back. And we see it has loaded the score. So it appears to work. Yeah, that's it. So it's working. So that's it for this video. Hope to see you again in another video. If you like this, please hit the like button. If you're not subscribed, consider subscribing. Goodbye. Have a lovely day.